Hello, welcome to a presentation all about tides, high tide, low tide. And this is a photograph taken at a town of Instow in North Devon in 2005 at pretty much low tide. We're all aware of low tide, high tide. Let's have a look. What causes them? So what causes the tides on Earth? Firstly, this is dedicated to my mate Nigel, who made me think about this one. I'm going to present two options here: the traditional model with the assumptions, the mathematical calculations of gravitational force, biblical scriptures, the stationary Earth model and assumptions, and mathematical calculations including Hooke's law. Buckle up. Traditional model, what do we assume? We assume that the Earth is a rotating sphere, the Moon is a moon. It means obvious, but it's a lower case. It's a solid planet. The Moon has a rotational orbit around the Earth. The Earth and the Moon exert an equal and opposite gravitational force on each other, and the effect of this gravitational force gives rise to tides on the Earth. So traditional model, here's the Earth, here's the Moon, the force of the Earth on the Moon, and the force of the Moon on the Earth. Newton's third law, these are equal and opposite. So we take the Newton's law of gravitation, which is F-grav equals minus g m1 m2 over r squared in the r hat direction, and we take the constant of gravitation, which is 6.673 times 10 to the minus 11 newton meter squared per kilogram squared. The mass of the Earth, as stated, 5.977 times 10 to the 24 kilograms. The mass of the Moon, 7.35 times 10 to the 22 kilograms. The average radius of the orbit, 3.84 times 10 to the 8 meters. And we substitute these values into that equation. And we're just worried about the magnitude, so we can ignore the unit vector. So you see the calculation's got all the values in there with the units, because that's good practice to show that we're expecting to have the units of force being measured in newtons, so all these should drop off as we go through. So the calculation is all that. Happy days, line by line calculation, ending up with 10 to the power 37 or 10 to the power 17 newton meter squared over meter squared. The meter squared cancelled out, and we end up with 1.99 times 10 to the 20 newtons, which is about 200 billion newtons. A pretty large force if we could ever measure that. The traditional model, here we have the Moon pulling here, and then we have a tide here on this side of the Earth, and there's also a tide on the other side of the Earth. The Moon's over here. I got asked this question years ago doing my teacher training by a chemistry teacher, and I thought it was actually a really good one. I've never forgotten it. How do you explain how there's a tidal bulge on the opposite side of the Earth when the Moon is over here, when it's allegedly the force of the Moon? And I've done a bit of research, and the best explanation I can find is it's tidal bulge due to the inertia of the Moon. So as it's going round, it's kind of the inertia left there. Inertia is a resistance to change. That's the best. Anyone's got a better explanation, please drop it in the comments box. What about a stationary Earth model? Well, we're going to assume that the Moon is a source of light and not a planet, so gravity doesn't apply. The Earth is a stationary flat plane. As water is incompressible, the Earth is in a closed system for a feedback loop performing simple harmonic motion by the action of atmospheric pressure, which is equally distributed across the surface of the Earth. And again, a bit of research, the average tidal range is 5.85 meters between 0 meters and 11.7 meters, and occurs every 12 hours and 25 minutes, which is 44,700 seconds. And the surface area of the landmass of the Earth is quoted as being 510.1, I think it is, million square kilometers. Biblical scripture, straight away, when you type in the word moon and her light, and light in here throughout the Bible, you end up with 4 verses where it talks about the moon and her light, 2 from the Old Testament and 2 from the New, moon and her light, moon and her light. So if it gives out a light, it can't be a planet, okay, according to the Bible. So that's people's choice to accept that or not. The stationary Earth model, we have basically a flat plane here. We have the North Pole in the middle, the South Pole going around the outside, the Antarctic, and you've got the distribution of the continents here, and that's the looking down as a flat Earth model. I prefer to say stationary Earth for obvious reasons. And taking a cross section, it would look like this. So you have the North Pole here in the center, and then you have the land mass here, L for land, I for inlet, S for south, the south here. So around the outskirts here, you've got like it's like a loudspeaker magnet where you have a North Pole in the middle and a South Pole going around the outside. And then of course this is all water here, and water underneath the Earth. So the atmospheric pressure of 1.01 times 10 to the 5 newtons per meter squared is a lot less than gravitational force, as we calculated in the first section. And what happens here, theorized that the Earth's surface is depressed slowly by the atmospheric pressure. So the atmospheric pressure is coming down with these arrows onto the Earth's surface. And you'll see that the water underneath, that's not going to get compressed, and that won't get compressed here. It's the motion, the force of the pressure of the atmosphere pushing down will depress the Earth's surface. When that happens, as the Earth is forced downwards and land mass is forced downwards, then the water from here will flow inwards. And the water flows inwards here, and the water flows inwards here to cover it up, to cause a flood tide. And then, as that's happening, the oceanic medium underneath the Earth resists. It starts to push back on the Earth coming down. And as it's pushing back, and then the waters gradually recede, and that causes the ebb tide. The water move there and that way and that way. It's quite a simple model. Always good to do calculations here. So we're given that the area of the landmass is 510.1 kilometers. So I've converted it all the way through here into 5.101 very carefully times 10 to the 14 meters squared. Then you've got that in the atmospheric pressure. Using pressure is force divided by unit area. The force is calculated to be 5.169 times 10 to the 19 newtons. So about 50 billion newtons. Assuming the range of 5.85 meters, we use Hooke's law to get the spin constant, F equals minus kx. Rearrange k equals F upon x. Put the values in there, and we end up with again 8.836 times 10 to the 18 newtons per meter. So it's a spin constant of the Earth's landmass, which is a huge number, which you'd expect it to be. The time period of the tide is about 12 hours and 25 minutes, 44,700 seconds. So using time period as 1 over the frequency, rearrange it, and then you end it in terms of per second. And omega is 2 pi times f, and we end up with 1.406 times 10 to the minus 4 radians per second. Getting everything into SI units. We now know the spin constant of the Earth and the angular frequency, omega. And then we can use this equation here. Omega is root k over m. Rearrange it. K over m equals omega squared. M omega squared equals k. So we're going to find the mass now is k divided by omega squared. So we've got k divided by omega squared. Again with the units. And Newton is a kilogram meter per second squared. Chuck in the units. Calculate it line by line. And we end up with the value of the Earth, the land mass of the Earth, as being about 5 times 10 to the 26 kilograms. The traditional model is 5 times 10 to 24. So there's a disparity there of about 100 times. So we've got this. So looking at the assumptions. So to conclude, the traditional model assumes the Earth is a rotating sphere, the Moon is a solid planet, and the Moon rotates around the Earth. The Earth and the Moon exert an equal and opposite gravitational force on each other, which causes the tides. The magnitude of the force about 200 billion newtons. The big issue is the tidal bulge. Question mark. The stationary Earth model is the Moon is a source of light, not a planet. The Earth is a stationary plane. Earth performs simple harmonic motion. Average range 5.85 meters every 44,700 seconds. The atmospheric pressure multiplied by the surface area of the landmass causes a force. The cause of tides, the atmospheric pressure pushing down, and you get the resistance coming back up. It's about a quarter of the magnitude of the force. How do we explain variations of tides? That's kind of a question for later time. And there's about 100 times difference in the calculation of the Earth's landmass I've got here. So that's the accepted value, and that's the kind of value that I've roughly calculated. Okay, here are the references as usual. Well worth having a look at, and any questions, please put them in the chat box. Please like, subscribe, and thank you for watching. Take care now. Bye bye.